Welcome to the class again. Dr. O here. Today I'm going to talk about elasticity. Elasticity in economics is a very important concept. But yeah, first of all, what is elasticity? We need to know. So from this week, during this lecture, I introduced what is elasticity, why it is important, why it is not used as a different measurement relative to slope. Yeah, we will learn about the connection between them and similarity, and all those stuff will be go over during this lecture. So most of all, what is elasticity? Elasticity, the words itself does have meaning, right? It is coming out from the noun form of elastic. So rubber band is elastic, right? Some material has the property have elastic, characteristics. But in economics, what is elasticity and what type of elasticity is used and why do we use it is the most important part. So we want to go through this. So understanding of elasticity and what type of elasticity exists in economics. And as we learned last lecture, we learned about supply and demand. So most likely we are using, or some of you already heard about price elasticity of demand, price elasticity of supply, and some other elasticity exist. So other elasticities will be discussed later part of this lecture. And next one is demand curve and connection between slope of demand curve, slope of supply curve relative to elasticity, price elasticity of demand and supply. All those things will be, discussed and explained during this lecture. So first of all, what you are going to learn is elasticity, elastic. So basically elasticity is trying to explain or measure the responsiveness of one variable change to affecting to the other variables. So especially demand relations, as we learned that law of demand is what? Price is negatively impact to the quantity demanded. And if it is a linear function, then the slope itself is kind of explain that, how much P changes, price changes, affect to the quantity demanded change. That is responsiveness. And we can measure that with the slope. But there is one problem. As long as you explain or think about and looking at the slope of it, we can measure the responsiveness price change to how much to the quantity demanded. So it's a negative relationship, so it's negatively impacted. How much is it? So if, for example, if the slope is -2, then price is increasing by 1, quantity demanded decreased by 2. That is responsiveness. But that makes some kind of issue in the sense of, or in the case of, we are changing the measurement or unit. Like a price can be measured with the dollars, measured with the Korean won, Chinese yuan, England pound, German mark, all different measure, Japanese yen. So under that kind of thing, we have a exchange rate to convert, dollar value to the Korean won value or Japanese yen, all those different type of measurement. Then price changes $1. That means that Korean perspective right now, like 1400 something. It's a close into the 1500 even. So those price changes, $1 changes of 15 or 1400 won changes, and quantity demanded changes by 2 in dollar value, but price change is changing so much. And in other cases, quantity can be measured the pound, kilograms, or all different type grams, and the per bushels or pound, all different type of measures exist, and the measure changes, slope changes dramatically. For example, $1 changes, the denominator should be 1, but now Korean won changes, denominator changes 1450, for example, 1, to the quantity changes by 2, right? -2 divided by 1440. The value itself changing dramatically. Very small number relative to the -2 to all those different value can be turning out if we're changing the measurement or unit. So under the cases, elasticity is very helpful to measure responsiveness of one variable to the another variable. So we can say elasticity is a unit-free measurement. Even though you change the unit, the elasticity doesn't change. So how we can define the elasticity? In general, we're starting with price elasticity of demand. For example, percentage change ratio, which is we usually slope measure, right? Delta P over delta Q. But instead of delta P over delta Q, we're putting in percentage change of P over percentage change of Q. But especially in demand, we know that impact is negatively related. P changes giving the impact on negative quantity demand changes. So that is the law of demand. We want to measure as responsiveness or elasticity, then we want to make it absolute value out of it. So bigger the number giving out more elastic relationship between two variables. So make the value positive. So absolute value you can say, or you're just saying negative instead in front of price elasticity of demand, because we know that law of demand is negative, right? Relationship between price and quantity. So the value is minus percentage change of P over percentage change of Q. Well, we need to learn a little bit about percentage change, from now on a little bit, and practice is necessary. But yeah, in daily life, we know that what is a percentage change. So if you're starting with the 10, the value is $10, and now the price is increasing by 11, then what is that? 10% change. Price increases by 10%. How we know it? So new value, 10 to 11, 11 minus 10 over 10. 10 over 11 minus 10. So 10 over 1, that is 0.1, which is percentage concept, 10%. We need to change it to percentage, then multiply by 100, right? So that is 10%. So those percentage change calculation, I think, I believe that you guys already comfortable with. Especially it is starting with the, simple number like a 10, because denominator is 10, then easy to calculate the value out of it. So my example was a simple, basic example. So yeah, during our class or in the exam situation, I will make, very simple calculation numbers will be coming out, but at least you can use the calculator and all those, machine, you can use it during that. So it doesn't have any problem, I guess. But as a giving the example purpose, I will giving a simple example for these lectures and also in the exam in general. But you can easily use the calculator as long as you know the concept of percentage change. So it doesn't have any problem, I guess. Well, under that explanation, right? Percentage change should be comfortably understood, and it should be comfortably translate to you, and putting in the equation easily you can calculate the price elasticity of demand, and later price elasticity of supply can be calculated. So the point is unit-free measurement. Even though you change the older unit as a quantity, pound, kilograms, meter, kilometer, centimeters, whatever value or measurement changes, it doesn't matter with using elasticity in that perspective. But slope itself dramatically changed. My example was the $1 changes, right? That is converting to the Korean won, 1440 won. In that cases, the denominator changed so much, and then the value of slope dramatically decreases. In that perspective, mathematically, the demand curve itself is flatter. So yeah, flatter demand, then responsiveness is less, but we need to measure with the unit-free measurement as elasticity is more precise under that comparison. So one more thing we need to note about is percentage change. Understand the percentage change. I will show you each one of the examples, and mathematical calculation is necessary. So I'll show you sooner or later. So elasticity, responsiveness of one variable changes to another variable. How the impact delivered to independent variable changes to dependent variable. So how responsive, how elastic the relationship between two variables. So functional relationship, causal relationship. One independent variable causes the change of dependent variable. That causal relationship can be the degree or the how much impact is on is measured by unit-free measurement. We are going to use elasticity. Well, elasticity is a several degrees. As we think, and at this point you can easily imagine that one side is demand, so price and quantity demanded is a dependent and independent variable relationship. So price elasticity of demand, that is one important measurement. And another one is we can apply easily with exactly the same concept to the supply curve. Supply curve itself, price elasticity of supply. So big two is price elasticity of demand and price elasticity of supply. And other measurement I introduced as a name. We considered two other variable huge impact on demand changes, demand shifter. What was that? Income and other goods price. So those two variables we are trying to measure how much impact is on of change of other goods price or income changes to demand shifter. How much is impact on it and how responsive on it. So elasticity can be measured. Under the case of income elasticity of demand, then the price as a causal variable as a denominator can be changed to percentage change of income, and change of quantity demanded change, percentage change of quantity of demand is numerator. By doing so, we can measure that elasticity. Income elasticity of demand can be measured like that way. Another way, price of other goods. So, like we looking at the example of potato, rice price changes, right? Other goods price changes, percentage change of price of rice, right? Rice prices, and then that is impact to quantity demanded change of potato. So, if it is negative, in the cases we will not make elasticity value to the absolute. In the case of cross elasticity, it is called cross elasticity of demand. So other goods price changes to whatever we are interested in originally. So potato or price change, potato quantity of potato relative to the price change of the rice. That is cross elasticity of demand. We will see one by one sooner or later. The next one we are going to go through today is each one of the shape of demand curve, and extreme cases and characteristic issue with shape of demand curve or supply curve. So we measured unit elastic as elasticity is equal to 1. So it's bigger than 1, we define as elastic. If it is less than 1, inelastic. So in general, price elasticity of demand, price of elasticity of supply can be measured in positive value. So 0 to infinity, we can imagine, but the standard or the baseline is 1. If it is bigger than 1, elastic, less than 1, inelastic. And infinite, perfectly elastic, 0, perfectly inelastic. So all those kind of things will be discussed in a minute with the examples soon. So from now on, we will look over all those other cases. Let's get into it. So first thing we are going to look at it is price elasticity of demand. Right now, looking at the topic right here, price elasticity of demand. The usual notation of price elasticity of demand is epsilon. So we are going to use E as a price elasticity, right? Elasticity. But E is taken as equilibrium or initial of it in economics already. So we are going to use that as a Greek letter, epsilon. So epsilon is conventionally we are using as the value or the notation of elasticity. So epsilon is equal to percentage change, right? So we can write in percentage change as a delta of P and percentage change of Q. So this one is a good summarize of notation or how to solve or how to get the price elasticity of demand. And as I told you, we can use that absolute value because elasticity measures the responsiveness. The bigger elasticity means elastic, less means inelastic. But originally we have elasticity in the case of demand. Demand cases is as we know, the law of demand negative relationship. So delta Q over delta P, the slope of demand curve is always negative in demand. So we knew this already. So we want to make the elasticity positive. We are going to use the absolute value, or generally we're using like this negative value of percentage change of P over percentage change of Q. So quantity demanded, then you can make name as subscript as a D. You can use it. So that is the formula. But sometimes we can do this as a percentage change. What is the percentage change? Percentage change is, let's say percentage change. Percentage change is, let's say 10 to 11. Then intuitively we know that 10% increase, right? How we can get this? The new value 11 minus 10 divided by original value 10 over 11 minus 10. That is nothing but 0.1. But it's a percentage notation. So we 0.1 times 100, that is changed to the percentage. So it's nothing but 10%, right? 10% increases. But one thing we need to note, if it is opposite, then it is not, exactly 10%. This is 10% increases, right? So we going that 11 to the 10, then original value is 11 to the 10, so new value is 10, right? Original value is 11, negative 1 over 11, so that is not 1 over 10, so this is not exactly 10%, 9% something, right? So you need to note that opposite side, but generally we know that 10 to 11 changes, then we can see that 10% calculation. So That's not that difficult concept, but this one's right. This one is the opposite side, then calculation is different. I'll show you the simple example out of it. But sometimes this one is like this. We can simplify it. So delta Q over delta P. Originally, this one divided by original value Q, original value P. That's nothing but percentage change. In other words, so delta Q over Q is nothing but percentage change of Q, and delta P over P is nothing but percentage change of P, and negative value is right here. So yeah, we can rearrange this as like this: negative delta Q over delta P times P over Q. So yeah, you denominator change it to the opposite side of it, right? So we can get this, simplify this like this. So sometimes we know the slope as a linear function, then slope is right here. And then, yeah, if it is nonlinear, this one is a derivative of a certain point, and we putting in the original value of P over P, Q over P, and then we can get the elasticity out of it. So calculation purpose, we intuitively we know the definition of elasticity as a demand as a negative percentage change of P over percentage change of Q. But if the value is given sometimes, then we can easily calculate using this formula. So that is nothing but, fancy calculation or derivation is necessary. You just solving it by putting in the definition out of it. You can get the value easily with this. Now let's talk about extreme cases, or some other cases we are looking at it. So as I explained before, like elasticity can be derived perfectly inelastic, or sometimes inelastic and elastic, and perfectly elastic. So these two cases are extreme cases, and by doing so, in the general cases is in the middle of it, elastic or inelastic, that can be measured by unit elastic cases, which is elasticity of demand is just 1. So inelastic means epsilon is less than 1. Elastic means epsilon is greater than 1. Perfectly inelastic means epsilon is equal to 0. Perfectly elastic means epsilon is equal to infinity. So all 5 cases, but it is just a baseline or default unit elastic, right? So it's a 1. 1 is standard or base to determine elastic and inelastic. By looking at it, you can understand easily. So let me see the shape of perfectly inelastic graph. So we're looking at the demand curve. Yeah, price elasticity of demand. In the demand cases, what is the perfectly inelastic demand? But perfectly inelastic demand is horizontal line. So what does that mean? So this is Q, this is P, right? So originally we interpreted as P as independent variable. It doesn't matter, it changes, like a P decreases or increases, for just giving the example. So if price, let's say 10% decreases, then usually quantity demanded should be increased by certain amount. But in this case, perfectly inelastic cases, quantity doesn't change at all. So Q, the change itself is 0 or 0%. Then the definition, elasticity is negative percentage change of P over percentage change of Q. So percentage change of Q is 0, percentage change of P is negative 10%, right? So we value to make a, negative to make always the value make a positive value. So it can be canceled out, and 0 over any number is equal to 0. So yeah, obviously this one is equal to 0. So perfectly inelastic demand, usually the shape itself is horizontal. So horizontal demand curve means that price, even though changes a lot, quantity demanded doesn't change at all. So price changes, quantity demanded should be responsive with the price changes, but it doesn't change at all. That means that perfectly inelastic cases. And other cases, let's see, right? So example, I will draw again. Demand curve downward sloping. So let's say P0 to P1. So it changes, as a simple cases, example, 10% decreases, and then Q changes. So let's say only 8%, Q0 to Q1, it is increases, but increases percent is only 8%. Then we can writing down, right, 8% increases the quantity, decreasing of 10%, minus then 0.8 is the elasticity. 0.8 is less than 1, right? So we define as this as inelastic cases. The standard of elastic or inelastic, right, is the basis are equal to 1. If perfectly elastic, the elastic means, unit elastic means, 10% price changes, corresponding to change of quantity, like 1. So in this case is 10% of price decreases, 10% of quantity increases, and elasticity is equal to 1. So it cases is elastic cases. So we can draw all the graph like this, and it can be used another like exactly same graph, but the magnitude is different, right? So I copy this. Paste here, and erase this red line and the corresponding movement. And again, the example is 10% decreases of price. Quantity demand is like if it is a little bit bigger, like this example, like let's say 12%, then we can say this, right? Elasticity of demand is negative, percentage change of P over percentage change of Q. So we can draw, this is a percentage change of Q, which is positive 12%, and this is negative 10%, minus is here, so 1.2, which is greater than 1, so elastic. Why? Unit elastic is 1. If elasticity is bigger than 1, we are defined as elastic. If it is less than 1, inelastic. Lastly but not least, we're looking at the another extreme cases right here. Perfectly elastic cases. So you can guess how does looks like in the perfectly elastic. So we looking at the perfectly inelastic cases is a horizontal line. Perfectly elastic case is the vertical line, but this one is a horizontal line. Demand curve looks like horizontal, then Yeah, that is perfectly elastic cases. So P0 to P1 doesn't change at all, right? But Q can be reacted with a Q0 to Q1. Even though price just tiny, as small value changes, dramatically quantity demanded increases. That's what we can expect as a, perfectly elastic demand. So it's huge relative to the zero. So let's say certain percent, like a 20% increases, even though price changes very small. Again, we can looking at the negative percentage change of Q, percentage change of P, percentage change of P is 0, right? And increases is, let's say, 20%. Denominator, so percent change itself is not written. So 20 over 0, which is, this is a negative 0, so this will cancel out. So that's 0 over 20. The value, some value divided by 0 is a huge number, so that's infinity. So the reason why I'm writing down negative 0 means that price decreases very, very small number, like a very close to the 0, decrease by it. By doing so, quantity changes increases dramatically. In opposite cases, price changes very close to 0 but increases something, Q should be decreases. That negative should be canceled out under this negative value to right here. So we will come up with positive maximum value, infinite value is coming out. That is why we are called this situation perfectly elastic. So perfectly elastic cases is horizontal line, and perfectly inelastic demand looks like perfectly vertical line. So now I hope you understand well about this, all the examples, each cases. So we looking at the unit elastic as elasticity of demand is equal to 1. So if it is greater than 1, that's elastic. It's less than 1, that's inelastic. So now let's discuss a little bit about elasticity and linear demand function. Linear demand function is given as an example like this. But one thing we need to be care about the shape of it and the functional form. So demand function itself, Q is function of price, right? Demand function is like this. And we draw like a Q is negative something P plus some constant right here as a intercept. So usually it is like this, right? If P is equal to 0, then Q is 60 right here. So 60 comma 0 is right here. But as I told you, we need to be careful about the slope and the show the graph right here is P is vertical axis. So even though you're looking at the negative 20, a negative half as functional form, but we actually looking at this as a 2. Can you see that? Why is that? Yeah, because we need to rearrange this with, by conventional looking, we should solve for P, right? P is equal to negative half Q plus 30, right? So by doing so, y-intercept or vertical intercept is 30, and the slope itself looks like, negative half. But originally, as we defined, Q is a function of P So this one is original, demand function of form, and how we to draw in the space of QP. You need to be careful about that. So let's see under these cases. So we in the textbook a little bit different about the point by the point, but I introduced a little bit differently with the elasticity. So we can measure with one point to the another point, like from here to here, we can measure the elasticity too. But also, as I told you, as long as the value is given, and especially in the linear function, I define a little bit differently right here. So percentage change of P over percentage change of Q. In other words, negative percentage change means Q over Q, delta Q over Q, Q over delta Q, and the denominator is a P over delta P, and rearrange this delta Q, delta P times P, Q over P. So we can rearrange of this, and then we know this delta P over delta Q is nothing but -2. So right here, then -2, negative and the -2, right? We can writing down, and we can plug in the value of it. Q value is, let's say, we wanna measure the at this point what is the elasticity. Then Q value, P value is here. Q value is 30, so 30 over 15. So this is a positive, right? And 2 times half, which is 1. Oh yeah, this is a unit elastic. So unit elastic point. So it's a point is given. Like usually we measure the certain point, and price elasticity we can measure with that. So as long as we know the calculus, if even though the function itself is non-linear, we can get it, because this one is nothing but, negative and then derivative of demand function at that point. So we measure the value out of it. At a certain point, we can find out the slope as a calculating derivative. And then putting in the Q over P and multiply by that, we can calculate the price elasticity out of it. So this is a unit elastic. Let's see what is the characteristic of this. So this one is expand to the 0 to 60. The midpoint is nothing but 30. And this one is going from the 0 to 30. The midpoint is 15. So linear demand function have a characteristic. In the midpoint, elasticity is unit elastic. Not in other words, elasticity of demand is 1 in the midpoint under the chance of the case of linear demand function. So, and then what we can get this. So how about this point? So this initial part is the same, right? Let's say this is point A, point B, and point C. So this one is point A cases, right? And B elasticity is, as borrowing this formula, -2 is here. And then the B point, the value of P is 10, Q is 40. So 2 times 1/4, that's half. So half is less than 1. So B point is inelastic. Correspondingly, you can get this as elastic. So you can find out this midpoint is unit elastic, go up, more elastic, go down, more inelastic. And if you can find out the value and you're putting in the value, you can measure with this value in the point of this, corner point correspondingly. And also, yeah, even though we just measure at the point elasticity, but also we can think of it, yeah, we can calculate the measure if the value changes A to B, which is point A is what? 30, 15, right? Q, P, coordinate 30, 15 to, let's say B is 40, 10. So we are measuring the elasticity of point A to the point B. So what is the elasticity of demand? The percentage change we can calculate, right? So percentage change of Q. Q is a new value is 40 minus 30. Original value is 30, right? And then percentage of change of P, which is new value is 10. Original value is 15, right? And the minus, so this value is a minus, so you can calculate this value. 1/3 minus, so this is a -5, -1/3, right? Then this is nothing but 1. Am I right? Yeah. So moving out from the A to B is unit elastic. So A to B we can measure or calculate correspondingly, and point elasticity, each one point we can use this formula to calculate the elasticity correspondingly. So percentage change is delta Q over Q divided by delta P, P over delta P. By doing so, we can calculate all the things in the, point estimation or point calculation, or correspondingly from A point to B, we can calculate the elasticity correspondingly. So both way you can do it, and usually we are doing more conventionally in the point elasticity calculations. And as I told you, the opposite side, B to A, yeah, it's I'll leave as the exercise for you guys, but this one is not should not equal to 1. So the value itself, the percentage itself is not like exactly same as this, because the value itself, so 40, 10 to 30, 15, obviously the base original value, so which is a denominator, can be changes correspondingly out of that. And the value, negative value, positive value, the change itself is the same, but where does it starts is totally different. So you will find out the different answer of this elasticity. So this A to B elasticity is just 1, and you can find out moving out from the midpoint, you can calculate the elasticity is a unit elastic. So those characteristics you can find it, but moving into midpoint is original value or original point is starting from where is determining the elasticity is inelastic or elastic. So you will find out by looking at it and try to solve these examples right here. Think about that, and if you have any questions, let me know in the Zoom conference later. Now I'm going to talk about price elasticity of supply. As long as we explain and we're looking at the price elasticity of demand for a while, so yeah, it's not that very difficult one. The epsilon s, then yeah, there is no negative sign of it, so percentage change of Q divided by percentage change of P, or percentage change of P over percentage change of Q. So this can be again, delta Q over Q, Q over delta Q, and delta P divided by P. So again, the shape can be summarized or simplified like this. But the difference is there is no negative sign up here because the law of supply. Price changes, quantity positively, changing it. So price increases, supply increases. So there is no negative sign involving in elasticity of supply. Elasticity of supply also always positive value, 0 to infinity is the value range. And yeah, we can see easily exactly same version, like perfectly inelastic and perfectly elastic, right? So same reason, right? Perfectly inelastic should have equal to 0, right? Any price changes, quantity doesn't change, so vertical line should be the 1. So price changes, increases or decreases, whatever it is, price increases. Yeah, quantity should increases, but the change P0 equal the Q0 equal Q1. So same, the change is 0. Then as we can define, that is Q, change of Q is equal to 0. P is like 10% or 20%, whatever it is. The value itself is equal to 0. So perfectly inelastic. Same region, same shape as a demand curve. Correspondingly, if it is horizontal line, then P changes a very small decimal. The increase of Q is dramatic, right? Small decimal decrease or increase of the price will make quantity supplied huge amount increases. That's why perfectly elastic, elasticity of supply is coming out. So P, change of P, percentage change of P is 0, is it 10% or 100%, whatever, then the value itself is infinity. And unit elastic case, so 10%, 10% correspondingly, we can looking at it. So P changes, P0 to P1, there is 10% changes. Corresponding Q changes is 10% increases, Q0 to Q1. Then, right, elasticity of supply, 10% divided by 10% should be equal to 1. So if it is increment is greater than 10%, the price is increased by 10%, quantity increases by 12%, that's elasticity of supply is equal to 1.2. If it is 8%, that is 0.8. So this one is less than 1, inelastic. This one is bigger than 1, elastic price. The price elasticity of supply, itself is elastic cases. So bigger than 1, less than 1 is the same measurement as we looking at price elasticity of demand. So same thing, same reason. The shape is upward sloping supply, downward sloping demand. That's only a difference. So we going over whole things before with this in the demand side. So supply can be easily understood in your side. So two other elasticity we are using is one income elasticity and another one is a cross elasticity. So income is the percentage change let's say epsilon I, percentage change of I, percentage change of QD. So this is obviously demand side, right? And this one, cross elasticity, is equal to percentage change of other goods. Let's say 2, P2, percentage change of Q1. So good ones, quantity demanded changes because of the change of price of other goods. So this one doesn't involving negative sign out of it. This one doesn't involving negative sign out of it because, we can find out the elasticity, the sign correspondingly we can measure normal and inferior. In this case, we can measure the substitute and complement, right? So cross elasticity is bigger than 0, positive value, then we can say substitute. This is less than 0, then we can say that is complement correspondingly. So by doing so, we're looking at the example of before, and we can measure that which changes of 1 or 2 income levels, and we can calculate correspondingly. But it is giving out the good indication of, like, as long as we know the elasticity instead of all the value. So in reality, we cannot directly see or observe the realization of exact demand curve or exact supply curve. But by data, we can measure that, price changes, quantity changes, how much percentage. That can be easily detected or can get out of data set. So in that perspective, sometimes a specific observation is right there. By doing so, we can calculate elasticity instead of we are not building up demand curve, all of demand lines or, supply functions. Because of that elasticity part, we can making a good policy suggestion on this matter. That's the power of using all the calculation out of it. So we making economic theory relative to or applying to the reality is really hard, but sometimes we can get some valuable information and valuable decision out of calculation like this. So in that perspective, elasticity giving us good indication to make better policy suggestion or guidelines of making a policy to interfering or to giving out or to support the market. So today we are going over to the elasticity concept. The important thing, elasticity is the responsiveness of one variable changes, especially price changes in general cases of supply and demand model to supply or to demand. So quantity demanded, quantity supplied. So price changes. So we define as a percentage change of price affected to percentage change of quantity demanded or quantity supplied. That's measurement of price elasticity. If we are looking at the demand side, price elasticity of demand, supply side, price elasticity of supply. So in that perspective, that's not difficult content to understand in that manner. And the other thing is other elasticity. We're going over the income elasticity of demand, cross elasticity of demand. So demand has 3 formats, right? Price elasticity and income elasticity and cross elasticity. So all those things can be discussed. And usually all the elasticity is a positive value except cross elasticity. Cross elasticity can be negative value, positive value. By doing so, we can determine, it is substitute or complement. So one variable to another variable, the one goods to another goods, the relationship we can verify with the slope or, the parameter in front of I or other goods price, or, directly measure with the elasticity, we can tell two goods relationship is substitute or complement. So that's not that difficult. We already go through that two goods relationship. So one more thing I emphasized in the beginning, the elasticity is originally invented to measured as a unit-free measurement. We want to measure the responsiveness or the relationship or how closely related and how much impact going on one variable price changes to quantity demanded or quantity supplied. But once unit changes, the slope itself changes dramatically. So it doesn't give us that correct information. Sometimes it's changes the value dramatically. So it is not good measurement. So we want to get a unit-free measurement. In that perspective, elasticity concept is well used so far. So today's lecture is a little bit technical in the sense of calculation, but the concept itself, you need to understand it, and one by one you solve or you see some examples of it. Pretty soon you can master up this concept. So this concept itself also really important and well-known concept and used a lot to analyze, supply and demand model, and then can say and give some kind of insight of some application, especially on revenue side or some policy issues. So sooner or later we will discuss a little bit deeper in that cases to how we can apply the policy by observing the elasticity and using the information about elasticity of demand and supply, and how we can make a policy under that certain target of market. So something is happening or we plan to do some giving out some impact on the market. What should we do under this information? Price elasticity of demand is a certain value and price elasticity of supply is a certain value. And by characteristic of it, we can make a precise or better policy philosophy or the approach to the market. So that will be the next time we will discuss. So today's lecture is understanding correct concept of elasticity, why do we use it, and how it is valuable information to analyzing the market. I hope you understand well from this lecture. Yeah, again, if it is not comfortable at this point, we will dealing with a little bit more example next time. So don't feel bad and try to understand well of these contents, and we will discuss a little bit deeper next time. Thank you. Have a good one.